everybody who comes through the program gets that experience of, I have a problem here and I don't know how to address it and I don't know how I'm going to get there and I don't know. But I know what my next step is. And that's really what we're trying to teach is you don't have to know every step along the way. You have to know your next step and your general direction. And then you can get to where you want to go. Eventually, you'll figure it out by doing the process of engineering this device.
Hello, everyone, and welcome to the Altium On Track podcast. I am your host, Zach Peterson, and today we will be talking with Dave Young, who has been seen on the Altium blog, but who is also president of Young Circuit Designs and co-founder of BlueStamp Engineering. Dave, thank you so much for joining us today.
Yeah, absolutely. It's great to be here.
Yeah, so as I mentioned, you have some articles on the Altium blog. What we'll go ahead and do is in the show notes we will link to those, and we hope some of the listeners will go and read those and learn a little bit. I think to get started, because you're a designer, but you also have an education program. I think to get started, it'd be great to learn a little bit more about your background and how you got started doing your own design firm.
Yeah. Gosh, I've been at my own design firm for almost 12 years now. Really, I design electronics for small companies and startups. So people who have an idea, maybe an initial prototype, maybe not. Somebody who wants to get their product off the ground and into beta testing and into initial manufacturing. I've been working with them. I started by doing exactly that, moonlighting for a small business who was trying to get initial manufacturing going, and I got that going, and we got them to the production phase. And then I thought, this could probably be a viable business to do for multiple clients at once, because as you know, when you design stuff, it's a ton of work up front, and then some validation and some tweaking, and then it's pretty much maintenance mode. So a small company that only has 3 or 4 employees, or maybe even 10 or 12 employees, they really don't want to keep an electrical engineer on after that big push of work. So that's where I thought, this is a great opportunity for me to jump in. And the other thing it did was it allowed me to leverage my, I have a broad range of experience from design work into manufacturing. And so being able to flex all of those skills was a pretty great opportunity I thought I'd take.
So working with small companies, I work with a number of small companies myself, and one thing I have noticed, especially recently, is a lot of folks that come into the electronic space and want to build something new or really advanced, or they're trying to be really innovative. Hardware is like another world for them. Maybe they came from software, and so they can do the application, they can do the firmware or something. But when it comes to actually doing the hardware, they just need guidance all the way through. Is that something that you found with the smaller companies you've worked with?
Yeah, absolutely. And in all fairness, everybody's got to go through that because the difference between what should work and what does work is very large in the hardware industry. So in the software industry or firmware industry, you can figure out what those things are in a stepwise manner. Like this should work, it doesn't, but I'll iterate here and it'll work, and then it should work and it doesn't. You can go. But in hardware, you got these big steps where you got to release a board, you've got to release a product, you've got to release plastics, you got to release all that stuff, and so you end up with these these periods where you realize like, uh-oh, we didn't anticipate this, and now our schedule's back 1, 2, 4 weeks. That was it's an uphill battle. So that's a lot of where the expertise comes in, and some of the experience comes in, where you can anticipate some of those problems. But even still, in trying to explain to somebody, they say all I want. The most dangerous thing a client could ever say is I just want. They have it in their mind that this is a simple thing, but in reality, to get exactly what needs to be there and what has to be in something for a successful product or a great launch, there's a lot of nuance and there's a lot of specific things that all have to come together at once for hardware.
Yeah, absolutely. And I've found that some of the clients that I've had coming from software, they have tried to get me or try to run it themselves like a software project. So they'll kind of create these milestones and I think it's a big disconnect for them in terms of what you've been saying, which is you have these phases that you have to go through, and you can't like do stuff in parallel, and you have to go through this specific workflow.
Yeah, and there's oftentimes ways to optimize. Like you can fit things in here and fit things in there and run things in two tracks. And there's a lot of cool stuff you can do to keep things moving and to spend money. And of course, as I'm sure you know, if you have a little amount of time, if you have a lot amount of money, that's okay. With hardware, it's like you can throw money at a problem, and all of a sudden your parts are there in 3 days. That is a thing to do. So yeah, it's a funny leap that folks have to take between expectation and reality on how to get hardware to a point where it's ready to be manufactured.
Yeah, the manufacturing seems to be, I think, one of the most, at least if you go through it your first time, in terms of the perception of it, the most challenging part. And so that's one of the areas where I think designers can provide a lot of value, is to know as much as possible about the manufacturing process, even if it's just like talking with manufacturers. Maybe you don't know how to, program an SMT line or anything, but you still at least know all the stuff that has to be done, and you can provide that perspective in terms of like, here's what you can expect when this is design is ready.
Yeah, yeah. Another big piece that I find is you know what is reasonable to ask of a manufacturer. So some people say like, well, can't you just take apart 1,000 units and do all the rework? And it's like, you could, you don't wanna. You could, but that's not a very efficient way of doing things. So the idea of let's make sure we do all this stuff up front so that we can get all the risk off the table, and then move forward. And that's really what it comes down to. I tried to articulate what we're talking about here with trying to get to manufacturing, how to deal with the nuances of developing hardware. And really, it comes down to taking risk off the table. So the sooner we can take risk off the table, the better off we'll all be. So let's identify what those risks are and figure out what path we have to take to get rid of those risks, so we can know moving forward, like, hey, this is a good design. It'll work not just once, but it'll work when we build 1,000,000 units, and it'll be ready to go. And that seems to be something that resonates with a lot of people, especially those that have an MBA degree or something like that, where they can say like, okay, I don't like risk. It's bad, and while probably nothing bad will happen, I know at least one bad thing will happen, so let's just mitigate all the risk so that we can get through and take the shortest path to production.
Yeah, risk is something that comes up repeatedly in discussions that I've had with that type of client. They're coming in and this is their first time, and for them the uncertainty can, I think, be paralyzing, which is why they want to come to a design firm that has gone through this process multiple times. But with risk, would you agree that oftentimes with the hardware level of risk, what's the best thing to do? Go to your manufacturer and get their guidance?
Well, yeah, it depends on the problem, right? I've got a
Sure.
lawyer who says I'm going to give you the answer I give everybody. It depends. But if yeah, particularly if you have a partnership with your manufacturing partner, like if you already have done a board that's of similar complexity and similar nature, similar test suite, similar, everything is very similar. It's super easy and super low risk. But as soon as people want some custom stuff or some unique things, now it's like, okay, so now we got to get that manufacturing partner involved, and we got to start talking to them about, again, what is a reasonable request and what is an unreasonable request. There are things that they have to do a little bit of work that can make a big difference for you, and then there's things that make a small difference for you, but is a huge amount of work for a manufacturing firm. And so sussing that out is really super helpful.
Well, and I still have, I encountered just recently someone who had the attitude of, well, they're the manufacturer. They should just be able to do what I ask them to do.
Yeah.
And I think once they get their first DFM report back, they suddenly realize that's not exactly the case.
Yeah, well, and the other thing is, that is true. It would be nice to go to a manufacturer and be like, hey, build this, and they would just figure out the details and make it happen. But no engineer wants that, because an engineer puts this part here for this reason and this in this use case, and the manufacturer won't know, like, oh, he's got this type of capacitor instead of that type of capacitor. If you're not plugged into the design, then they cannot deviate from what you have put in that design. So, asking them to not change the design yet make it perfectly manufacturable is a tall order. It's a good thing to strive for, to be sure, but yeah, it's a tall order. But that's
Well,
where those
and
conversations happen, like I mentioned.
then the manufacturers, some of them will actually just modify stuff for you, just to get it
Yeah,
into production. And I
yeah.
mean, maybe for
Especially this
something.
year.
I'm sorry.
Especially this year, because like nobody can get any parts at all, and so they'll say, "Hey, I can keep production rolling if I'm allowed to use this part instead of this one." It's like, yes, thank you.
Yeah, I didn't realize the extent to which that actually happened until actually we did a YouTube video, but I actually got to talk to Kelly Dack. I'm not sure if you know who he is, but he and I had like about a 20-minute conversation about solder mask, and I didn't realize how much something simple like solder mask might get modified by the manufacturer just to ensure accurate assembly, account for misregistration, things like that.
Yeah, yeah, and those are the things that you really do, unless you're doing some like super sensitive analog measurement stuff. Those are the kinds of things that you really. It's great to have a manufacturing partner who would say, "Hey, I take this solder mask off and I can increase yield by X%." That's really great feature that they do sometimes.
Well, and for me, the issue was, really high density, but we weren't doing an HDI board.
Oh yeah,
So we had to know, like, okay, what's the solder mask limit that we can have in terms of, slivers and openings and things like that.
yeah,
And then, of course, I
yeah.
talked to the expert, and he says, they're probably going to modify it for you.
They're probably going to tweak it. Well,
Yeah.
and the thing is, that's what you want, right? You want them to go and say, like, well, we put it through the process, and it is easier for us to really dial in this solder mask process than it is for us to dial in our reflow oven or whatever it is. And that's where that conversation is so helpful because they're running boards all day, they're making all this stuff happen, and so keeping that triangle of designer, manufacturer, client all in the loop and everybody on the same page. Um, yeah, a lot of emails, a lot of phone calls.
Yeah, oh yeah, yeah. The email chains are always fun. Um, and speaking of dealing with clients, I mean, I think entrepreneurship, just in general, and going this route, is one way for a new designer to really break into the industry and kind of make their mark. I mean, what drove you into entrepreneurship, and what
Yeah.
were some of the challenges you faced? Because I mean, I know my path, but everybody's got a different path in terms of starting their own firm and getting into this industry through the path of entrepreneurship rather than going through like a big OEM.
Yeah. Um, yeah. So for me, the entrepreneurship path is I like working in small teams where everybody has a lot of responsibility and it's very clear that everybody's on the same team, putting their shoulder against the same problem and working towards a solution. And the other thing is everybody on these small teams, if you work in the entrepreneurship ecosystem or in the entrepreneurship community, it's all about let's move together to get as far as we can. It's a lot of fun to work in that environment, and so really that's where I picked up, and that's I like to move fast but move well, and so that is a good way to work in an entrepreneurship environment. Like you're not doing anybody favors to do something quickly that's not going to work in the long term, but at the same time, taking forever, doing the 13-month development cycle that doesn't need 13 months is not a great outcome either. So it's just a place I found myself happily working, and so one thing leads to another, and next thing I know, I'm just making more products and making more products and making more designs.
So I was just thinking as you were talking, my difficulty with getting into the industry was coming from academia. Like the way we talk about what we do and what we know how to do is totally different, and actually I think kind of off-putting for people in industry because it's always like what you know and what you learned,
Yeah,
and not like here's the value I can create.
yeah,
And learning how to communicate what you can do was like a big shift for me. And it was once I learned how to do that, I think it was actually really helpful for like landing some of my first clients. And no one had to like look at me and say, oh, I think this person can do this, I'm going to talk to them. It was, I can show you that I can do this, and then I was able to engage people. But my route in was through freelancing. Um, I mean, do you think that's probably the best way for someone to get into the industry and really, kind of cut their teeth and getting some of their first clients, and hopefully they're successful and they build it up. I mean, I kind of see that as like, that's the classic path of entrepreneurship. You know, it kind of starts small and it's, you know, in your garage, and then eventually you build it into, you know, your empire.
Yeah, yeah, that is. I mean, that's a classic approach. Personally, I worked as a senior engineer for years at Keithley Instruments, and that was super helpful to
I've
get the
used
tech
many
down
of Keithley's
and to
products.
learn from some of these really great analog engineers working on very, very challenging measurement problems and very low level precision, high speed. It was a spectacular experience. I could not have started Young Circuit Designs right out of college. Like, there's no way in a million years. And I had some circuit experience from college, and I had done some co-ops, and I had built some things on my own. But even still, that all pales in comparison to the experience I had at Keithley. And so, working on a team where people are really smart, really capable, and can get a job done, and have a lot of that experience, say like, you don't want to do that because of X, Y, and Z. It's kind of that short circuit to get to a successful outcome. So working there for years was really helpful. And then starting to go out on my own. And to your point about nobody wants to talk about what they know. I want to talk about what I can do, or more specifically, really what I found to be super helpful is talk about what I've done and how it's similar to the problem that you are now facing. Because if you can show that you've been down the road, you've tried something similar, you've learned a few of the pitfalls, it's going to be a lot faster and more efficient for the clients to hire somebody who's done something similar. And that's really, so in my opinion, the best way to do stuff is to start doing it, whether it's not for money or for hobby or for something. If you want to get into any arena, the best way is to dive right in and to get after it.
Yeah, as they say, jump in the deep end and learn to swim.
Yeah.
Yeah, that's how it was for me with my first manufacturing run. I had a pretty extensive DFM report come back. I'll admit it.
Ah.
There were some things that needed to be changed, but it's okay, right? I mean, you as successive runs piled up, the list of requests got shorter and shorter and shorter, and that's exactly what you want to see. But I like what you said, because if you're able to identify where you messed up and what the solution is, and then say, here's a pitfall for you, let's address that now, and that's going to reduce your risk. I think that's extremely valuable if you're running your own firm, or even if you're just working at a larger company, and you can see ahead of time, like, here's one of the risks, we should think about this.
Yeah. Like you said, if you can address that at the beginning, it's always super fast and super cheap to address all of those things at the beginning. It's kind of annoying to go through it. And I've had multiple clients roll their eyes at me and be like, guys, we got to do a board review before we send it out, even silly prototypes, even something that's dead nuts simple. I'm going to sit here and I'm going to run it through my process. It's going to take time and it's going to be annoying. It's going to take me half a day or whatever. But I got to run it through my process, even for like a one LED, one connector board. It's got to go through the process, because there are always things that come up if you don't look.
Yeah, and I think one of those important ones, because I just luckily caught this on a recent project, was footprints.
Yeah, I just had that experience earlier today.
Yeah, when they make the footprint from the bottom view versus the top view.
It's always something. It's always something.
Yeah, it's always something. Yeah, if only they were interchangeable like that. Although I guess with some back-to-back Schottky diode arrays, you can get away with that, but most of the time, not at all.
Yeah, there's already, but why bother? Why not just spend the 30 minutes and go through the review process for how do I make sure all my footprints are rock solid? It's like, okay, well, I'm going to take all the parts and I'm going to look at each data sheet. I'm going to look at each pin 1, pin 2, pin 3, pin 4. And hey, it takes half an hour, especially if you were the one designing it. It takes half an hour, you do it, and then you feel great about it, especially if you've got somebody else making the footprints for you. Now it's so common to find footprints from all different sources and bring them in because they're just a click away. You bring them in, and to have blind trust on those. Like I said earlier today, I was dealing with a situation where that didn't work out and had to make an adjustment for a downloaded component.
Yeah, I will admit, even though in Altium there's like the manufacturer search panel and it has footprints in it, and then there are some external services that will make a footprint for you. There's even like Snap EDA, where it's like community based. I think those are all good resources to get like 80% of your footprints, because 80% of your footprints are going to be what, like 0603, packages or
Yeah, and
something
you
like
already have
this,
those.
or it's going to
It's
be,
no problem.
yeah, it's going to be an SOIC, right? So if you don't have them, you can go get them easily. But like, what about that fine pitch BGA
Yeah.
for that one integrated circuit that makes everything work?
Yeah. Yeah. Yeah, I totally agree.
Yeah, that's always fun to make yourself.
I've got a dream that one day with the downloaded or with the cloud-based components or whatever, I've got a dream that somebody will make a standard, maybe IEEE or something, will make a standard for how a chip manufacturer can document what the footprint should be like. And so there will be one standard of, this is my document of where I want the copper, where I want the silk screen, where I want the solder mask, where I want everything. And then it is the responsibility of the CAD software to interpret that and bring it into their design. Because the problem with like EasyEDA and all those other ones is you have to trust that their system is going to work the way it should. And if it's not native to the program you're using, whether it's Altium or Eagle or whatever, it's like, I don't think I trust this. It's sitting there doing, it's like you can watch it doing its little script or whatever. It's like, what are you messing up right now? Because I'm not on the same revision, or I'm not on whatever that should be the same way. And I think that's the solution, where there is a native interpreter of a standard, like a IEEE controlled standard of, this is what a footprint document should be like for a CAD file to read. And then you can just go to the website, you click and download it, and you're off to the races, and you can have some confidence. But for now, all those things, who knows where they come from? Who knows what it's going to look like? It's yeah, they're just not trustworthy.
Well, you would have thought that would have been solved already multiple times over.
Yeah.
And it seems like the CAD vendors or the parts search engines of the world just keep defaulting to, like, we're just going to like throw model files at you, and hopefully it all works out.
Yeah. So it's gonna be like 50 clicks to get it imported, plus I got to review it. Great. And at
Right.
that point,
Yeah, right.
Meanwhile,
Yeah.
I can design the component in. So like, if I'm an Altium, I can do the IPC footprint wizard, and within 25 clicks, I could be done.
Yeah, exactly. Yeah. You're right. You're right. And it's going to be IPC compliant, because that one at least is programmatically generated, and it's kind of hard to go outside of the predefined range.
Yeah. And for 95% of what I'm doing, I know I'm gonna be good. I might need to tweak things. I might need to tighten some stuff up, maybe change some solder masks or whatever. I don't know. But it's great. So if we can get to that point, like, that is so programmatic, and that's defined by a standard. It's all, like, you look at the data sheet and they document it. We're so close to being to the point of being able to, the chip manufacturers, instead of giving the stuff on the data sheet, to give it as a file that a CAD program could pull in. It's like, so close. So close.
That's actually a really interesting idea. So it's like a file you download. There's an interpreter built into the CAD tool that follows a specific standard, and you can't mess it up. And then even the files could be standardized.
Exactly.
Right? So
you go get something from TI, you get something from Analog. It's exactly the same. Then the CAD companies know what's going to happen. Everybody knows what's going to happen. It'll be limiting. Like, to be sure, you won't be able to have, like, the tight, medium, and spaced out board options or whatever. You maybe have 3 footprints, but I dream of the day when I can download a footprint and not feel like it's a time bomb waiting to go off on me.
Yeah. So on that note, with footprints and sourcing and components and everything, I mean, it's I think this is one of those elements where if you're dealing with clients, like, this is one of those things that is so foreign. Like, oh, shouldn't I just be able to, like, click the component out of the catalog and it just just works?
Yeah.
Sometimes.
I mean, you just described the PCB CAD industry as a whole for the last, at least the whole time I've been designing stuff. Is clients are always stupefied by the tool that I'm using. It was like, wow, that's pretty involved what you got going there. That is not like using an iPhone.
Yeah, what exactly am I looking at here?
Yeah, and there's so many buttons and features,
like
and the names change, and Lord help you if you got to switch to a different package. Like, if you got to go from Eagle to Altium or back or whatever, it's like, oh, this is very difficult to manage.
Yeah, definitely. And then when you actually, like, send this stuff out for production, assuming you got it all correct, then you have to guide them through that process and, choosing local versus overseas. And I think I'm a little more fortunate because like a lot of what I do is either ITAR explicitly
Yes,
or
you
it's
know
dual
what you got to
use.
do.
Well, I mean, the manufacturer is like 10 miles
Yeah,
away. Like,
yeah,
I can call them on the
yeah,
phone,
yeah. And all you got to
If I've
do
got
is
a
write. All you got to
problem,
do is write the big check. Like, okay, write a big check so I can
sure.
get ITAR, and I'm gonna have all the things that I want.
Yeah,
Pretty great.
exactly. But I've had a bad experience going overseas in the past, and I've dealt with a CM that does overseas when it's not one of those types of
Hmm.
projects. But I don't know if I would have the patience to deal with a manufacturer where I have to like call them at 2 in the morning because I'm in the U.S. Let's say they're in East Asia. I got to call them at 2 in the morning, or I
Yeah.
have to try and deal with this over email, and maybe there's a language barrier, to put it kindly.
Yeah. Plus, you get one chance a day to solve the problem on email, right? Here you go. Here's my one
Oh
email,
yeah,
and then tomorrow they're gonna email. Tonight they're gonna email me back, and then I'm gonna get in. I have the whole day to decide what my email is gonna say, but I got one email today to settle it. Is very challenging. That's for sure. Personally, I just like to stay up until 2 a.m. rather than draw things out over a week of emails. That, yeah, I'll just stay up. I'll stay up.
well, I mean, I have a support staff that's
Yeah.
overseas, so I'm lucky that I'm already up until 2 a.m. So
You
I
got to
guess if I
talk to
really
them
needed
anyway.
to deal with, yeah, I got to talk to them anyways. So I guess if I needed to, I could, get on the phone with, some guy in, China or Vietnam or wherever
Yeah.
and deal with some kind of manufacturing issue. But I think a lot of clients, once they realize, what goes into manufacturing, they really start to appreciate the local approach and going with someone local, even if it's not ITAR or
Yeah.
dual
Yeah, and
use.
I've had a lot of that. And actually, surprisingly, I know China's locked down or whatever, but I quoted a prototype board. Um, Domestically, it was $400, and to get it offshore was 200. And if I went domestic, it'd be a few days faster. And it's like, wow, that's not. I'm used to like a 10x cost difference, where if something's $400 here, it's gonna be 40 offshore. I was surprised it was only a 2x cost difference. It was like a 2x. I'll buy the extra couple days and make this project move faster.
Well, and the cost, when you just see the number, like it leaves out a lot of context because I think some companies overseas they'll hit you with the like, oh yeah, buy quantity 20 for like five
Yeah,
bucks each or whatever,
yeah,
right? And then of course someone sees numbers like that and it leaves out a lot of context in terms of processing capabilities, in terms of quality and inspection,
hmm,
things like that, in terms of just even
yeah,
layer count,
yeah,
little stuff like that, and it all adds
yeah.
up. And people just don't realize, no, here's the board you want, and here's what they're going to get you for
Yeah,
$5 a
right,
board.
right. And then you end up just spending the 200. By the time you're done with all your upgrades, it's like, oh, it's really a $200 board. Got it. Okay.
Yeah, exactly.
And it takes 5 days to make instead of the quoted 24 hours. So yeah, yeah, it's pretty tricky. So I'm hoping that maybe we'll get some more volume back domestically. It starts to make more and more sense. And once the cost, the other thing that is, I know it 5 or 10x cost difference is a striking multiplier. It's like I don't want to pay 10 times as much for my boards, but if it's a cheap board, you know, it's a couple $100 difference. It's obnoxious to spend extra money, but for a couple $100 to save a lot of hassle and risk. Again, it's about pulling that risk in. So all you have to do is go through one experience of boards getting stuck in customs, and, and you're like, oh well, that was a bad deal. I shouldn't have done that. And there are no customs between my local board manufacturer, and me.
I have had to order some parts from overseas recently because I mean, as we all know, it is impossible to get some parts, or someone overseas will buy it all
Yep,
up as soon as it
yep,
hits
yep.
DigiKey, and then they turn around and 10x
Hmm.
it. But I have had to buy some parts overseas recently, and occasionally I do get hit with the, oh, your box is held
Held
in
in customs.
customs right now. It's like,
As soon
oh
as that
my
happens, as
god,
soon as I
you
see
know.
that, I have it set so it'll give me an alert. As soon as that happens, I reorder the boards. It's like, I don't know.
Oh
Yeah,
really?
because I don't know if it's going to be a day or a month that they're going to hang on to them. So I can't wait. I just another $200. Sure. Here's your $200. Let's do it again. And sometimes it
Oh,
comes
that's a lot
quickly,
of
but
fun.
there was one time where it was in mystery land between customs and DHL. I just took forever.
Yeah, I don't want to, badmouth any of the shipping companies, but I will say because of the customs issues, I've preferred to avoid DHL for importing into the
Yeah.
US for that exact
Is that
reason.
right? Maybe that was my problem. Is I use DHL. I've always felt like they were fastest, but the yeah.
Again, not a official endorsement of any shipping company on behalf of myself or Altium, but I will just say that I have never had a problem with
Okay.
FedEx going international.
Okay. Okay.
So, food for
Yeah.
thought.
That's maybe I'll change that up.
Yeah. Yeah, so I mean, I guess the what you're saying here is something that the industry is starting to maybe wise up about in terms of the costs and the headaches and the risks associated with going overseas for some products. I mean, I don't think it makes sense to manufacture, every, circuit board for a microwave in the
Sure.
U.S. But maybe the circuit boards that go into, stuff in aircraft
Hmm.
carriers, we should probably keep
Yeah.
domestic.
Well, that's for sure. But
Yeah.
on top of that, I found that the location of the box build is also a big factor. So if you're the rest of your build is in an offshore facility, then all of a sudden offshore PCB manufacturing makes sense. But I have a few clients that are doing onshore. It's domestic PC or domestic box build and sourcing your boards from offshore. It's like the other thing is the percentage of cost. I know it's 2, 10, 5x cost, but the percentage of that cost increase in terms of the whole picture, because PCB assembly for many of these products is pretty inexpensive relative to the rest of it. It can again take a ton of risk off the table, especially at the early stage when you're trying to move fast and change things quickly and get things done and turn things around. It's like, oh, we can't get this part, we got to change this quickly, or oops, we forgot a piece of tape here, we got to open them up. Like, all of those things are so easy to deal with here. Um, it's just fast and low risk. So that's why I've been pushing people on low volume things, and then I always say, well, when you're ready to go high volume, we can look at going offshore and we can see what that value proposition is. But it's a conversation for later.
Yeah, and that transition to offshore, as I mentioned, I've had a bad experience doing it myself, but then, trying to run high volume offshore, um, that is something where there's a manufacturer that I work with that
Mm-hmm.
does, they do small volume all the way up to, tens of thousands of units. And when I have a client that's ready to go and scale and they are considering offshore, I'm like, okay, here's the manufacturer that I work with, and I'm going to send you to
Mm-hmm.
them, and they're going to take it over. And at some point, I'm no
You're gone.
longer in the picture unless it's like, hey, why did we place this here? Or is this going to be a compatible
Yeah,
swap for this component? Those kinds of questions. But at some point, I'm out of the loop and I'm on to the next thing.
sure. Yeah.
Yeah, I think that I think that is a good way to handle it, especially in the initial stages with companies who are not electronics
Yeah.
pros, let's say.
Yeah.
So I think I'd like to switch gears for a moment because in the intro I had mentioned that you were the co-founder of BlueStamp
Yeah.
Engineering, which is actually an educational program, and I'm really interested to hear about this because, as I'm sure you're aware, there is maybe a workforce shortage on the
Mhm.
horizon if we don't do something to get more kids involved in electronics engineering and STEM education.
Yeah. So BlueStamp Engineering, I've been doing for I think this is our 11th year. We're in the middle of right now. We're running both in Palo Alto and remotely. Um, but the program was designed to get high school students to do what I do. So basically, let's get you to build a project that you get to pick and that you get to keep, and we'll just help you along the way. So we hire our staff members are typically graduate and undergraduate students who have a ton of project building experience and are excited about it building and are they're happy to be building all summer long with a bunch of students. And so we get into a room and we build a bunch of stuff and we document it and we publish it and we put it on the web and then we carry on. So it was an experiment that a friend of mine and I had kicking around ideas on a train platform when we were much younger, and we tried it out and it was like, wow, this isn't just a little good. This is like really good. We we found that it was a ton of fun, and the students, what they learned, and the things that we didn't anticipate was their ability to be more independent and to be more confident, to feel like they can do things on their own, to be self-motivated, to feel like I can do this. I don't need anybody's help. Just give me the internet. And that is a game changer for students, especially students who haven't had a ton of exposure into the open-ended problems. So it's a transaction thing with school, where school says you do this, they do it, and then they get an A. Like, that is the process that many students are used to, and it is not great for training engineers, because as we all know, you go out and say, hey, build me this, and you go and you work at it for a while and be like, this is good. It could be great if we did X, Y, and Z. Maybe later, maybe now, maybe whatever, we can have that conversation. But having these open-ended problems, or you wanted me to build this, turns out it's impossible with the technology and the budget and the time. We need to have a conversation, figure out how we can change things. And engaging with that unknown and being comfortable with it is something that is not typical in the current high school curriculum. And so the unique nature of what we offer in the program is it's a lot of fun. And it's representative of everything that we do as engineers.
This is really interesting because you brought up something about the education system more broadly that I think a lot of people miss, but you described it as transactional, which I think is really interesting because, like you say, you do this thing and then you get some kind of credit for it. Mm-hmm. And mm-hmm. It sounds like the way you've structured this is they have to do something, but the objective that they have to achieve to receive some kind of credit, mm-hmm. and even the idea of what that credit is, mm-hmm. neither of those things are clearly defined.
No, well, yeah, they're generally defined without too tight specifics, and the other thing is they're defined by the student. So they are not accountable to me or any of the staff. They are accountable to themselves. So they say, I really want to get this experience and build this project, and I want to get to this goal, and so they go for it. And so some students, it's like, wow, this is really hard. This library is deprecated, or this part's unavailable, so I got to pivot this, I got to pivot that, I got to work through all these problems, I got to figure out how I can make it work. And so they get a huge challenge that way. And other students, they blow through the project, it goes exactly to plan, and they have a whole bunch of extra time. And then what we do is we ask them to do modification. So invent something new related to your project to make it totally unique or totally new. And so everybody who comes through the program gets that experience of, I have a problem here, and I don't know how to address it, and I don't know how I'm going to get there, and I don't know. But I know what my next step is, and that's really what we're trying to teach, is you don't have to know every step along the way. You have to know your next step and your general direction, and then you can get to where you want to go. Eventually, you'll figure it out by doing the process of engineering this device.
Yeah, and I think that's where the big divergence is from kind of the traditional educational model, which is, like you say, they may not know each of the steps, but it's almost like the act of the figuring out the steps, like that in itself is so important. And being able to figure out, here's what we don't know, here's where we can try and go look for it. If we can get that figured out, then we can address this next thing. Yeah,
one step at a time. We'll get there. Big problem, lots of little problems. We got to break it up and put it back together again. Yeah, it's a lot of fun. And it really, again, it's just so similar to what I do, particularly being a design consultant, where I have clients, like you mentioned, people are coming in all the time like, hey, I don't know how to do this. Help me out. Let me get this going. He's like, hey, I don't know either, but I am confident I'll be able to figure it out. And so you go and you work at it and you go through that whole process. And the reality is engineering is building things that haven't been built before. And so the definition of it is making it up as you go along. Sure, you got processes and techniques and education and tools, and you have all these things to help you essentially make stuff up. And you give that to a high school student, they're like, really? That's awesome. I would like to do that all day long. So yeah, it's a good time. And it's just as the accomplishment is the same. The accomplishment I feel when I finish a project for a client is the same that the students get. And I feel like that dopamine hit is one of those things that if you are an engineer, if you're like, you have the Dilbert knack, it's like, ooh, I want more of that. Let me build something else. And that's what we're trying to foster.
I call them the eureka moments.
Yeah.
when it works and it's like, oh my gosh, it works, you know, even if it's just something simple like, oh my gosh, I got this 555 timer circuit to work. Look at the bulb, it's
Yeah,
flashing. It's so cool. But like for me when I was younger, you know, when I was a student, like and you know, I mean, I did physics, but we still had to do, you know, all the
yeah,
electronics
yeah.
classes and stuff. All of those moments were so important because it like reinforced like I can actually do
Yeah, it's
this.
not just drudgery. So many people think engineers. Like I talked to some of my cousins in my family, or some people, some high school students who don't know about BlueStamp Engineering. They think that guys like me do math and physics problems all day long in a cubicle, and it's like, oh no, I do math and physics problems. Small piece. I get to build stuff and make things happen. That is the big piece, and is really so much better than just doing problems.
Yeah, yeah, and for me getting into this industry, it was a big shift for me because you know you described as doing math and physics problems all day. Like when I was doing my research, like I worked in lasers and
Mhm.
optics and stuff before doing this, but I actually had to do that. I had to sit in front of Mathematica for a lot of hours writing up a script to analyze all of the data I had just captured from whatever you know
Yeah.
experiment I had to build. And this is a big shift, and you still do some of that, but you're right. You're not just sitting in the cubicle all day running
No, totally
simulations.
different.
I hired someone to do that for me. So
And I assure you, they're trying to figure out how to get promoted out of that job.
yeah, yeah. I mean, they also write, which is enjoyable for some
Okay.
people. I think that can also be tough, and
Yeah.
but I mean for students, one thing I've been you know trying to I don't know figure out is the right word, but one thing I've wondered about is like what gets the next generation really engaged and want to jump into hardware because you know I had talked about this with Judy Warner last
Yeah.
year, and you know I had mentioned that like when I was teaching engineers that nobody wanted to do circuit board design.
Yeah.
You know, I most of my students when I was teaching physics were actually engineering students because all the engineering students have to take physics,
Yeah.
of course. And then of that group, maybe 80% of those engineers were electrical computer
Yeah.
engineers.
Yeah.
You
Yeah.
know, there was an ECE program at Portland
Mhm.
State where I taught. But those students, like, they all wanted to go into
Mhm.
semiconductors. Every single one of them. Or they wanted to do, like, maybe they were doing civil, or maybe they wanted to do automotive. But, like, PCB never really factored into
Mhm.
it, or maybe they didn't know about it, but that wasn't, like, the goal.
Yeah.
Or maybe they were doing like firmware, or maybe they're doing you know embedded, something like that.
Yeah.
But there was never like PCB design at the forefront. And you know where I'm at in Portland, like we have a huge Intel campus
Mhm.
up here.
Mhm.
So of course you know Intel's over there recruiting and stuff, and they've got all their you know people out there, and they do seminars and that kind of thing. So I think it's understandable to an extent, but I've wondered like what is going to get the students to maybe shift towards manufacturing, shift
Yeah.
towards PCB design, look at it from the systems perspective and realize, okay, it's not just the chips and it's not just the programming. Like we're actually building an entire system.
Yeah.
And is that, you know, do we have to kind of like capitalize on one of those other areas to try and like get students to like pivot and realize, oh, I can actually build an entire thing here if I just know how to design the PCB?
Yeah, yeah, you know, I think you're right. I think that actually most students, when they want to do that, when they feel passionate about doing something like that, they end up switching from electrical to mechanical engineering. Because there's so many people I know that we're in the electrical engineering, and they're like, oh, but I could build all kinds of cool stuff down in the machine shop if I do mechanical engineering, and all I have to do is take a few thermodynamics courses. It's like, okay, I'm gonna do that. Uh, yeah, so that's I think that's where a lot of them go. And then for the electrical engineers, you know, for the way Blue Stamp does it is we get them excited about the experience and the end goal, and then the tools are side feature. It's certainly cool to be able to use all the different tools like the CNC and the 3D printer, and we do make boards, custom boards at Blue Stamp. We do a lot of that stuff, but those are the side dish to the experience and the end result, the end product. And that seems to be super motivating for most students. Is like, yeah, I'm gonna learn how to do board design so that I can do this other thing, or so that I can do this extra thing, or so that I can move forward. And so it's, you know, it's always like keep your eye on the prize, We want to learn how to be awesome at doing this one skill, and we want to have the resulting, one of the projects is an alarm clock that you have to shoot a Nerf gun at to get it to snooze. So, they want that in their room, and then they also want the experience of writing code and learning about piezo's and learning about microcontrollers and learning about, LEDs and alarms and buzzers and all that kind of stuff is exciting, and that's really where we focus.
I've been a big advocate of talking to the student who equates technology with coding to get them into hardware design. Because, I mean, just look at the media. I mean, whenever the media talks about tech, what are they talking about? Facebook, Google.
Well, that's where the money is.
Sometimes Apple, but
that's where the money is.
Yeah,
especially the new money.
Yeah, exactly. I mean, yeah. I mean, you look at the software developer salaries and the fact that you don't have to learn how to like physically build something doing software engineering, and I see it as a very low barrier to entry with a very high success rate. And so it makes sense that students are going to want to go the coding route. And so I've often thought that, number one, we need to capitalize on that group of students and show them that, hey, there's this whole other area of where you can work in that is just as rewarding and, frankly, financially rewarding if you can then, leverage those coding skills in electrical engineering.
Sure.
But then also, I mean, with modern designs, like there's going to be some component of that somewhere in some of the most advanced stuff. Like there's going to be an application somewhere that interfaces with this product that you're building, whether it's embedded firmware, whether it's an OS, whether it's a web app. I don't really care where it's at, but it's somewhere. So coding enters into it.
Yeah. Well, the other thing is we have so few firmware engineers right now. It's like we would really do well to peel some of those firmware engineers away from the software. Alicia White, she does a class for software engineers that want to get into firmware. And I was talking to somebody who just recently made that jump. It was a colleague of mine who used to write just code on a computer and now writes firmware. And he was like, you know what the most annoying thing is? This thing's not doing what it's supposed to. There's probably a note about how it can't do what I'm asking it to do in that 1,200-page reference manual. And I don't know how to figure out what it is. Were this a computer, it would just do everything I want all the time, whereas this thing's got some tiny piece of molten sand that says, we can't do that one thing that you want to do that you should be able to do. It is very frustrating. I gotta hand it to him. It is a challenge. It's super fun to work on something that's so small and you can ship it in a box and make it do all kinds of stuff, but it's and many times it's a hard fought battle.
Yeah, I like that you brought up the 1,200-page reference manual because, dude, I don't want to read that.
No, I don't want to read that. I barely want to search it, and I don't even know the terms I should be searching for right now. So, and sometimes you just got to sit down and you just got to go. Hopefully they have a table of contents, and you got to read that 30-page section on why port B doesn't do an output when your ADC is running. It's like, oh, God.
Yeah, and that can kind of kill you on the board design end too. If you didn't realize it, then you have to go back in and change something in the board as well.
Yeah. The other funny thing to talk about when people make this jump is like, have I explained to you what erratas are? Because you're gonna love this. Oh. They said they would do it, but then they decided that they can't do it, and they're not updating that document for you, so that you're gonna have to read the other document about the document that was wrong. Boy, they love that.
Oh man. Yep. Yeah, exactly. And then you got to hope that if there is a reference design for that chip, it's well documented enough to where they put a little note in the schematics. This port will not work if this ADC is running, or whatever it is.
Whatever the nuance.
Here's why we put. Yeah, here's why we put these configuration resistors here. Refer to page whatever in the data sheet. Yeah, that would be a very nice if everybody did that, because, I mean, starting with reference designs, I think it's actually a really great way to just learn about a chip and its supporting components. Careful with the PCB layout, but if they could document that stuff as best as possible, it's really a useful tool to make sure that you're going to be successful with using that product.
Yeah, absolutely.
Cool. Well, I would encourage anyone who is listening to check out the show notes and learn more about BlueStamp Engineering. Can we link? Is there something we can link to? You can send
Yeah,
to me?
BlueStampEngineering.com is the best way to find us.
There we go. Perfect. BlueStampEngineering.com. Go check it out. Learn more about the program. I am a fan of any of these educational programs that is going to try and get the next generation of kids and students interested in design at any level. I don't care if they're in high school or grade school or they're starting a graduate program.
Yeah.
I'm a fan
Or
of
just
all of
making
them.
a transfer from one section of the career to another. You can do it. You're 80 years old. You can transfer from being a software engineer your whole life to writing firmware.
There you go. Perfect. Dave, thank you so much for joining us. We've been talking with Dave Young, president of Young Circuit Designs and co-founder of BlueStamp Engineering. To anyone that's listening, please check out the show notes. We've got a lot of great links, and you can read some of Dave's blogs on the Altium website. And also, are you okay with people connecting with you on LinkedIn?
Yeah, absolutely.
Maybe learn more about BlueStamp?
Yeah.
Cool. Yeah, we'll include a link to his LinkedIn profile, and yeah, thanks everybody for listening. If you haven't already, make sure to subscribe to the channel, hit that like button, and last but not least, don't stop learning, stay on track, and we'll see you all next time.